Hi guys, look what I have on my repair station. It's a Hewlett-Packard 54616B Oscilloscope, and this belongs to one of my friends, and he gave it to me to try and repair it. So I agreed to have a go at it. So the current status is that it switches on, and you can't see any illumination on the screen, but what you can see is lines going across the uh, oscilloscope, some green lines. So I am hoping that it is just a display problem. So I agreed to open it up and see what's happening. So I've been looking over some videos on YouTube about repairing one of these oscilloscopes, and there is a very nice video done by Dave EEV blog, and he goes into many aspects of the oscilloscope, the power supply, how to check the power supply, then how the rotary encoders work and all that. So I'm not starting from scratch, so I have that video as reference, and I have he points the way to many documents on the Hewlett-Packard website, now Keysight website, and I'm not starting from scratch, so I have a head start. And of course, Dave, on his oscilloscope there was a problem with the keypad area, so I'm hoping that, and it would have proved to be a very difficult repair, but I'm hoping that this won't be so difficult. So let's crack it open and see what we can do. So I opened up the back cover of the oscilloscope, and it's very easy to open the back cover, and there are several videos on the YouTube on how to open it, so I'm not going to go into that. And first thing that you should do is check the power supply voltages, and I checked most of these are the power supply points that you should check, and I checked all the power supplies, minus 15, plus 15, plus 5.2, and a negative supply also. So all the power rails correspond to the repair guide, and so there is nothing wrong with the power section of this oscilloscope. So this is the top side of the oscilloscope, the CRT, the neck connector, the video amplifier, and at the bottom you see the display board, and on this side you get the switch mode power supply, and the rotary encoders which are on the front panel, and the cooling fan, and this is the connection which goes from the power supply to the electronics at the bottom, and from the bottom you get the data and power to the display board. So this is the display board. I have took it out, and it's very easy to take it out. But I still have the connector still connected to the tube. I will see whether I need to take it out, or whether I can replace or do whatever the repairs that I need to do just by having it here. So I will assess whether I need to take it out, because it's a bit of an operation to take it out. Not that you can't, you have to be careful, you have to discharge the high voltages and all that. So I will assess whether I need to take it out. So looking at the board, you can see a whole bunch of capacitors, and I have seen many videos which says that the capacitors over here and other electrolyte capacitors might have problems. So what I'm going to do is I'm going to first of all replace all the capacitors, and then I just happen to have capacitors with me, all the all the relevant capacitor that goes on this board I do have, so I'm going to replace that. And there's one more the IC, which is this MUPC1379 IC, which is the sync separate IC for this board. And since this is a display problem with the horizontal lines going across the board, so I'm suspecting that IC, so I would get a new one. I don't know whether I can find this IC, especially since it's the lockdown period and most of the shops are closed. So I'm suspecting this IC, and I want to replace that one and see whether it makes any difference. So let's get to those things first, and we'll see what happens. So I replaced all the IC, not all the ICs, the sync separate IC, and I replaced the capacitor, the electrolyte capacitors, and I also replaced this logic circuit 74LS03 here, and then I put back everything together and powered on the oscilloscope, and nothing. The problem is the same, and it is not giving me any positive response. The screen is giving the same horizontal green lines, and it has not changed a bit, so looks like it's going to be a difficult repair. So I've been now I started concentrating on the digital side of this board, and like I said, I have there is a very good video from Dave, who probes all these signal points. So first thing I did is to check whether the clock input for the microprocessor, the MC68HC000, is functional. So clock input is comes to pin number 11 or something. Anyway, I know that it is the 6th pin from this side. So let's see. Yes, and you can see on the oscilloscope it's 10 megahertz, and the clock input is fine. So let's what I found out is that there is no bus activity on the microprocessor after the initial burst of activity. The bus activity on the address bus and the data bus just ceases to happen on the microprocessor, as if it's waiting for some input. So it ceases all operations and just waits for something. So I'm just I'm suspecting that it is waiting for IRQ or something like that. Because there are few ways that this microprocessor can be stopped. It should the halt input should go low, or the bus error input should go low in order for the microprocessor to stop. But I find that all those inputs are high. It means they are not asserted. So technically the microprocessor is running, but no bus activity. So I'm suspecting that some input, it's waiting for some input which is not coming. So let's see what we can do. So while I'm at it, I also checked the output to the video board, the display board, and the HSync, VSync, and the data enable signals were. It's not the pulse width and the frequencies are not what the service guide is specifying. So that leads me to think that there is something wrong with the display buffer or something. The data that should be outputted to the display board is not in the correct format. It's not according to the service guide. The pulse width and the frequencies are not within specifications of the service guide, so that is making me suspect one of these display related chips here. So if one of those ICs are gone, then it puts this oscilloscope beyond any possible repair that I can handle. So let's hope it's not the case. So I was looking at this board through my thermal camera, fluke thermal camera, and I noticed that these 3 chips are getting warmer than the other chips. So if I can touch them, yes, they are pretty warm. It's almost that I can't keep my hand on them for long. It's very warm. It's not warm. You can say it's very hot. So I'm suspecting that maybe there is a short in one of those. But then again, all 3 chips cannot be warm at the same time. And then I googled the part number, which is it's a 10K HP54616B IC. It turns TTL into ECL logic. So, and the data sheet says that they can get very hot due to the voltage differences. So I'm inclined to think that it's okay. So let's I don't think there is anything wrong with it. So what I did is I also desoldered one of them and switched on the instrument, but nothing happened. So I don't want to damage the board, so I did not remove all 3 chips. So because I'm pretty certain that they are not the culprit here. So at this point I'm totally lost as to what is causing this problem. There's no bus activity on the microprocessor, but there is some display signals coming to the display, but they are not the correct signals. So as far as probing it with the oscilloscope is concerned, I have come to a dead end, and I've been thinking about it and doing so many various tests, and I know that the display is good. I mean the display side is good, the CRT is good, video board is good, everything is good, but it has to be something to do with this digital side, but I am at a loss at this point. So my next plan is to turn to my trusty Huntron Tracker 2000, which is sitting over here, and it's an analog signature analysis device, and see whether I can find any leaky ports on the logic gates. It's a long shot, but let's see whether it can shed some light on this board. So guys, I've been working on this oscilloscope for the last week, and I've been down chasing many rabbit holes and ending up empty-handed, and I almost gave up, but I found something unusual on one of the buffer ICs. It is this one over here, and it's one of the pins was suspect when I was observing it through the Huntron Tracker, and let me show you what the pattern was on the Huntron Tracker. This is the pattern that this one of the ICs gave me, and I've been looking at logic ICs long enough to note that that slight curve at the extreme corner indicates a leak. So that to me is a leak. So I've decided to chase that and see whether that particular IC is leaky, or it can be other ICs which is connected to that pin. The only way to find out whether that IC is leaky is to remove it and see whether it has a leak. Okay, by now I have found the problem, and I'm happy to say that I have rectified the problem by now, and the oscilloscope is working. So let me go through what transpired after my last update. I've been chasing that leaky pin which originated from this pin over here, and I traced it to see that it is also connected to this pin. It's a 74LS244, and I thought I lifted this pin and to see that the leaky pattern is not coming from the pin but from the pad, and then I traced it back to this pin. I lifted that pin also, and again found out that the leak is not on the chip and it is from the pad. So that indicated that the leak is not on this chip, but it is connected to some other chip which is connected to both those pins, and then I found out that it is these two pins are connected to a similar chip, similar IC on the other side of the board, which is also a 74LS 244, and without lifting individual pins, I just remove the entire pin on the other side of the the entire IC on the other side of the board, and again found out that IC is also good, and obviously the leak is coming from a different IC. So then I again traced it. I investigated where those pins are connected, and it finally led me to this IC here, which is a 74LS or 74LS not 8, but and it had a open pin which is not connected to anything. It's a quad AND gates, 4 numbers of AND gates, and one of the outputs, one AND gate, is open. And what I did is I looked for a 74LS not 8 on my inventory, but I could not find any 74LS 8 not 8s. So I replaced it with a 74HC not 8. Yes, I know that they are not 100% compatible, but hey, it works. And I've been observing it for some time, and the IC is not getting hot, or neither are the other ICs which is connected to it are getting unduly hot. So I suppose that it is, as far as I'm concerned, it's working. So I'm going to keep it in there. I'm not going to take it out and replace it with 74LS not 8. I think it's doing the job. So that's it, folks. So let me switch on the oscilloscope and show you how it looks now. So let's see whether my repair is successful. Of course, I know that it is successful. Just switch on and see how it looks now. There the HP logo coming on, and there it is. It's a success. So thank you everybody. That's my video for the HP 54616B Osilloscope repair. It's everything is working. All the buttons are working. Auto scale is working. Everything is. I need to plug in the memory module on the back side and do some finishing touches, so my friend will be happy. So thanks again, and goodbye for following the video. Bye bye.